This is a problem from section 6-4, a problem similar to your homework. We have 3 randomly selected households are surveyed, and the number of people in the households are 2, 4, and 9. Assume that samples of size n is equal to 2 are randomly selected. With replacement from the population 2, 4, and 9, find the possible samples. So each sample will have a pair of numbers, and the numbers can repeat. So if we select 2, and we select 2 again, probably don't want to say 22, so let's say 2 and then a little dash into 2. So 2, 2 would be one sample. 2, 4 would be another sample. 2, 9 would be a third sample. And then now we say the first number we chose was 4, and then so it's 4, 2, 4, 4, and 4, 9. And then suppose the first one we chose was 9, we get a combination of 9, 2, 9, 4, and 9, 9. Part A says we want to find the variance for each sample, then summarize the sampling distribution of the variances in the format in the table where we have to find the probability. Well, first let's find the variance. Let's see if we can do it this way, where we find the variance of each of these things. Now, if you have 2 of the same numbers, then the average is going to be that number, and there's no variation between those numbers. So the variance, if you have the 2 numbers that are the same, is 0. If you want to double check that, we can go to your calculator. Let's go to Stat and Edit. I have some stuff in my list, and let's just work with L1 right now. I'm going to clear L1. So I go up to the number L1 and I hit clear and enter, and then I'm going to put the 2 numbers in my sample, which is 2, 2, and then I'm going to see if I can find the standard deviation and then square it to find the variance. So to find the standard deviation, I'm going to hit Stat. Let's go to Calc, and then 1 var stats, and then I'm just going to do a 1 var stats on L1. And then I see that the Sx is the sample variance that I'm looking for, and the sample variance is 0. So the sample variance of that is 0. Now let's go back to our list, and let's change this to, instead of 2, 2, let's change it to 2, 4. And then now let's find the 1 var stats again. So second function, or stat, calc, 1 var stats. And then here I got my standard deviation to be 1.4142. Let's go with that and let's square that. We got 1.999. Let's just call that 2.0. Now the variance for 2 and 9, let's go to Stat again, Edit, 2 and 9, and then let's do the stat and 1 var stats. And it looks like I have 4.9497. Let's go with 4.9497, and let's square that. And I get 24.499. Let's go with 24.5. Okay. And so now I have 4, 2, which we've had before, and we found that it's 2. We have 4, 4. Since it's the same number, we know that standard deviation is going to be 0. We have 4, 9. We don't have that yet. Let's do 4, 9. Let's go to Stat, Edit, and I want to change the first number to 4. The second number will be 9, and let's find the 1 var stats for that. So this is 3.5355. Let's go with 3.5355, and then let's square that. And then I get a 12.499. Let's go with 12.5 for that one. The 9 and 2 is the same as the 2 and the 9, so that's 24.5. We got a 9, 4 again, which is the same as 4, 9, which is 12.5. And 9, 9, since they're both the same number, it's going to have a standard deviation of 0. So here is our list, and so now we just want to identify them and have them as our random variables. So I see 0 as one possible variance, and let's count how many there are. There are 9 samples, and we have 1, 2, 3 zeros. So the probability is going to be 3 out of 9. I suppose we can simplify that to 1/3. I'll just keep it like that for now. Let me change the color on this to say that I've already counted it. And so the next number I see is 2. So let's add that as another variance. And how many of them are there? There's 1, 2, and I think that's it. Out of 9, so there's 2/9 probability to get a or to get a variance of 2. The next variance is, if I'm just going in order, I see that 12.5 is next. And there are 2 of these guys also. 1, 2. So that's 2 out of 9. Just counting them as a probability. And then the last one is 24.5. And there are also 2 of them out of 9. So these are the probabilities that we have. The next question asks us to compare the population variance. The population variance is denoted by sigma squared. So you got sigma is the population standard deviation, and you square that, and then you get the variance. So let's compute the variance for the population. We're looking at the population has 3 numbers, 2, 4, and 9. Let's go to our list again. 2, 4, and 9. And then let's do a 1var stats. I have here my standard deviation for the population, and now I have to look at sigma because it's asking us for the population. So it's 2.9439. So I'm going to go with that, and then I'll square that so that I'm actually looking at my variance. And I have 8.6665. So let's go with 8.67, or just 8.7. The next thing we want to compare to is the mean of the sample variances. So I'll denote that in a kind of a strange way. I'm going to use x bar, and then I'm going to use a subscript of the variance. So in order to find that, I have to go to my list of variances from up here and then find the mean of that. So let's go back to our list, and then I want to put those numbers in. I have a 0, a 2, 24.5, 2, etc. So here my list is done. Let's do the 1var stats on this guy and find the mean. And here the mean is 8.66667. So let's call that 8.7. And then look, it matches. So we found the population variance, and then we got the mean of the variances. And so here it matched. So this tells us that the sample variances are going to be a good estimate for us to use our procedures in the future chapters. All right, so I hope that helps.